So the 2013 question, a solid metal hemisphere has a radius of 12 centimeters. Calculate the volume of the hemisphere. Give your answer in terms of pi. Okay, so the one good thing about area and volume is that the formulas are in the log tables, okay? So right back to the start of your log tables, which starts at page 8. This is length and area, so this is working out the area of 2D shapes, okay? Or the length of it, of course, the main length being the circumference. Okay, on page 10 then we go on to 3D shapes, which is all about surface area and volume. So when you get a volume question like we did here, calculate the volume, the first thing you do is you go to this page and you find the right shape. Okay, so our shape here is a hemisphere. So we're here in the log tables. I have a cylinder, a cone, a sphere, and a frustum of cone. Okay, so a hemisphere, hemi is always means half. A hemisphere is half a sphere. Okay, so it's like we chopped him across the middle in half and you're getting the volume of a hemisphere. Okay, so half a sphere. So in your log tables, A is curved surface area, V is volume. So it tells you up there in the corner, okay? So I'm here at the V equation. So V is equal to 4 over 3 pi r cubed. That's for a sphere. So you can get the area of the entire sphere and then divide it by 2 at the end. Or of course, you could go half of that formula. So it depends how comfortable you are with fractions. That of course puts 2 fractions into it and that makes some people uncomfortable. So that's why some people work out the volume of the full sphere and then divides it by 2. So whichever way you want, I don't care. So the volume of a sphere is equal to 4 over 3 pi r cubed. Okay, just let's have a look. 4 over 3 pi r cubed. Okay, so it's equal to 4 over 3. That's a constant. It's just a number. Pi is just a number and a radius. Okay, so a solid metal hemisphere has a radius of 12. So 12 cubed. Put that into your calculator exactly as it's written there. So 4 over 3 by pi, so shift, you see the by 10x button down the bottom, that's where pi lives, or pi lives even, by 10 cubed. And cubed is up the top under the alpha button. And I am getting for that 2304 pi. Okay, so therefore volume of a hemisphere is equal to half of 2304 pi. So in my calculator, I'm just leaving the answer there and hitting divide by 2, and it's 1152 pi centimeters cubed. And of course it's cubed because it's a 3D shaped, which is the cubed that's here. So that's how you find that volume of a hemisphere. So once you have that formula in the log tables, actually it's okay. All right, a solid cone of radius 4 centimeters and height 12 centimeters is cut from the hemisphere. Okay, so in the diagram here, there's this cone and some machine is cutting that cone out from this solid hemisphere. Okay, so a bit like arts and crafts. Calculate the volume of the cone. Okay, so in the same way, I would go volume cone. Okay, and you can see I always write my shape here because you can see the volume, the V formula changes depending on it. So again, volume, V for volume, this is my cone. So a third pi r squared h. So a third pi r squared h. Okay, where h is your height. Do you see that? It's your height of your cone and r again being your radius. So calculate the volume of a cone. So it is equal to a third by pi by my radius is 4 squared by that height h. Okay. And put all of that into the calculator again. Make sure you're doing it with me so that you make sure you can put things like this into the calculator. So 64 pi, and it's again volume, so it is centimeters cubed. Okay, so in terms of pi, you see there was 2 there that says in terms of pi. That means you just leave that pi in the answer like that. In other words, you don't multiply it in. Okay, because if you remember from national school or first year, pi is a number, it's got more decimal places, but it's 3.14. Okay, so that number is the same as 64 by 3.14. Okay, so if you hit S to D on your keyboard, you will see that you get for here 201.06. Okay, on my in my calculator, I'm putting in 64 by 3.14 to get the rounded version, which is 200.96. Okay, and that's just because this was rounded to 2 decimal places. Pi in your answer here had all the places, so this one is more accurate. So your answer isn't 64. In fact, it's 64 pi, which is the same as 201. Okay, it just means we haven't multiplied in the pi, and we do this to avoid rounding errors. Okay, what it normally means in a question is that in some section you're going to end up cancelling pi's. Okay, I'm going to guess here and here we're going to end up cancelling pi's. So rather than have rounding errors, they leave it in terms of pi. It's more accurate. Okay, so part C then says the remaining metal. Okay, that's important. The remaining metal in the hemisphere is melted down and recast into cones of the same dimensions as the cones above. How many cones can be formed from the remaining metal? Okay, well, the first thing I would say is how much remaining metal is there? Well, that's 1152 pi minus 64 pi. Okay, so I'm just going to take them away from each other. 1152 minus 64. So I am getting 1088 pi. Okay, so the remaining metal is melted down and recast into cones of the same dimensions as the cone above. How many cones? Well, if that's how much metal I have, and that's how much one cone costs, so how many cones? Okay, I take my remaining metal and I divide it by the amount of metal it took for one cone, and I see how many I get. Okay, and I get 17. Okay, so what ends up happening here is the pi's cancel. But that your calculator will do that for you anyway. So how many cones can be formed from the remaining metal? It's a 17.